Hi everyone, this is Mr. Stancikevich, and we're going to talk about how to graph basic sine and cosine functions today. Our equations are going to be in the form y equals a times the sine of bx and y equals a times the cosine of bx. And there are two characteristics of these graphs that we're going to pay particular attention to today. First is the amplitude, which is a, and second is the period. So we're going to be paying attention to amplitude, period, and interval today. And we're going to see how that affects our graphs. Okay. Now, capital A tells us the amplitude. So the absolute value of A is going to give us the amplitude of our graph. Now you may wonder, what does he mean by amplitude? What does that describe? Well, as you see when we begin to graph, I'll explain further what amplitude means. Period. The period tells us how long it takes for the graph of the sine or the cosine to repeat. Period tells you how long it takes for the graph to go through one cycle. So that's the length needed for the graph to repeat. Okay, and what's going to give us the period is the value of b. So we're going to say that period is equal to 2 pi over b. And then interval is something we use in the graphing of our functions, and an interval is going to be found by taking the period divided by 4. So we're going to find that by taking the period over 4. So the parts that we are really interested in are how we find the period, how we find the interval, and how we find the amplitude. That's what we're going to concentrate on in this assignment. So, looking at our first two functions, sine, y equals sine x, and y equal cosine x are called parent functions. These are the most basic, the simplest equations we can have for sine and cosine. If we can get good at how to graph sine and cosine, then we can graph any form of this function when we begin to add other numbers and change them. So I go to graph y equals sine x. I go to graph any of these functions. And the first thing I want to do is I want to figure out what is the amplitude. Okay, what is the amplitude of this graph? And that's found, remember, by looking at the number in front of the function, which in this case is 1. So the amplitude of my graph is 1. The period is found by taking 2 pi divided by b. b, remember, is found in front of x. It's the number in front of x. So when I look at y equals sine x, the number in front of x is also 1. And so the period is going to be found by taking 2 pi divided by b, which in this case would be 2 pi divided by 1. And so the period is 2 pi. It will take 2 pi units for this graph to get back to the beginning, to repeat itself. The interval, which we use in drawing our graph, is found by taking the period divided by 4. So my period is 2 pi, so I'm going to take the period divided by 4. The period is 2 pi. I divide that by 4, and that's pi over 2. Now, if some of these numbers look familiar, pi over 2, 2 pi, that's because the graphs that we're doing now of sine are related to what we're doing with the unit circle. A unit circle takes 1, 2, 3, 4 quadrants to pass through That's why there are 4 intervals in our sine and cosine wave. So I go to graph. I move out from the origin 1 period, just some random distance, and put a tick mark. That's 1 period. I'm going to cut the period in half, so now I have 2 halves. I'm going to cut each of those in half again. And I now have my 4 intervals. Now remember, each interval is pi over 2 units. So this first tick mark, starting at the origin, the first tick mark is 1 pi over 2. The second tick mark is 2 pi over 2, or 1 pi. The third tick mark is 3 pi over 2. And the fourth tick mark is 4 pi over 2, or 2 pi. And again, if these look familiar, those are your quadrantal angles, which refer back to your unit circle. Now the amplitude tells me how far above and how far below the midline. The x-axis right here is called the midline, the middle of the graph. And I will go 1 unit above and 1 unit below the midline. Now, the parent graph of the sine always begins at the origin. So I put a point at the origin. And moving to the right along the x-axis, I now move up so that at pi over 2, at the end of my first interval, I put a point at 1. Continuing to move to the right, now the wave, the graph is moving down. I'm back at the midline at pi. I put a point again. The third interval, at 3 pi over 2, I'm down at the bottom of the wave. I put a point at -1. And then continuing to move to the right, I'm continuing up towards the midline. And I put a point there at the midline at 2 pi. I now draw a smooth curve that connects all 4 of these points, and there's the graph of sine. Sine wave. The graph of the sine is a wave, and you can see that it takes pi over 2 units for this wave to get back to where it started from. Notice at the origin it was increasing to its maximum. When you get to 2 pi, it's increasing again as it reaches the origin. Cosine, same process. I want to find the amplitude, the period. Cosine is the same process. I want to find the amplitude, the period, and the interval before I draw anything on the graph. The amplitude is the number in front of the cosine, so that's 1. The period is 2 pi divided by the value of b, and that's the number in front of x. That's 1, so 2 pi divided by 1 gives me a period of 2 pi. And each interval is the period, 2 pi, divided by 4, so each interval is pi over 2. You'll see that most of them today will be with a period of 2 pi and an interval of pi over 2. On the graph, along the x-axis, I move out 1 period, some distance. You can pick that, make it rather large, use your whole axis. I move out 1 tick mark, that's 1 period. I cut that in half, and I cut each of those in half again, so there are my 4 intervals. I label them. The first interval, starting at 0, the first interval is 1 pi over 2. Going another interval, that's 2 pi over 2, or 1 pi. A third interval gets me to 3 pi over 2. My fourth interval is 4 pi over 2, or 2 pi. The amplitude is 1. So along the y-axis, I go up 1 unit, I go down 1 unit. Now the graph of the cosine is different than the graph of the sine. We said the graph of the parent function for sine starts at the origin. The graph of the cosine starts up here at 1, and then moves down to the midline at pi over 2 after 1 interval, continues down to -1 at the end of the second interval at pi, moves back up to the midline at 3 pi, and then at the end of its fourth interval is back at the peak where we started. I draw my smooth curve again, connecting these 4 points, and there's the graph of the cosine. 1 period of the cosine. Sine and cosine Waves. The graph of the sine and the graph of the cosine is a wave. Now I go to the next one. Graph the following, y equals 3 sine x. I need to find these three characteristics of the graph before I try and draw it. The amplitude is again the number in front of the sine. Remember, we're following y equals a sine bx. So a is the amplitude, that's 3. The period is 2 pi divided by b, that's the number in front of x, that's 1. Should not be surprised. I said most of the problems today are going to follow that. And then the interval is the period, which is 2 pi divided by 4. When you reduce that, you get pi over 2. Again, should not be a surprise. I said most of them today are going to have an interval of 2 pi. Now I go to the x-axis. I go to my graph. I draw out one interval, some distance along the x-axis, and put a tick mark. Again, make it rather large so you have plenty of room to work with. I cut that in half. So now I have two parts. Cut each of those in half again. There are my 4 intervals. Each interval is pi over 2. So the first interval is 1 pi over 2, 2 pi over 2, which is 1 pi, 3 pi over 2, 4 pi over 2, which is 2 pi. My amplitude, though, now is 3. So when I move up on the y-axis, I label that 3, and I go down to negative 3. Same distance down, negative 3. Now, where does the graph of the sine start? We go to our parent graph to be reminded. The graph of the sine starts always at the origin. So y equals 3 sine x starts at the origin because it's the graph of the sine function. Moving to the right, we move up so that at the end of the first interval, I'm at the maximum. Draw a point. The next interval, I'm down at the midline. The next interval, I'm at the minimum. I'm at the bottom at negative 3. I draw a point. And then I start back up again so that at 2 pi, the next interval, I'm back to the midline. Draw my smooth curve. And here's one period of the sine. Y equals 3 sine x. Let's see if we can get one or two more in here. Let's go to a negative. What happens when there's a negative in front of my function? Okay, what is this negative? What's the consequences of that? What does that do to my graph? Well, as we saw, amplitude is the absolute value of that number in front of the sine. So the absolute value of negative 1 is positive 1. Remember, amplitude is always a positive number because it represents a distance. So it's always a positive number. Just go with it. Amplitude is always a positive. Even though it was negative in front of the function, when you write amplitude, you write it as a positive. The period is still going to be 2 pi over b, which is 1, so that's 2 pi. And the interval is going to be each period divided by 4, which again is still 2 pi over 2. I go to my graph, I go to the x-axis, I draw out some distance and put a tick mark, cut it in half again, label my intervals. The first interval after the origin is 1 pi over 2, then 2 pi over 2, which is pi, 3 pi over 2, and then 4 pi over 2, which reduces to 2 pi. My amplitude is 1. So I go up 1 unit and down 1 unit on the y-axis. The graph of the sine, again I'm reminded with my parent function, the graph of the sine always starts at the origin. So in this graph, because it's sine, it starts at the origin. So what does the negative do, you ask? The negative, as I move along the wave, as I start at the origin and move to the right, normally we would go up. But because it's negative, I now go down. And then repeat the pattern that I had before. So now the graph of y equals negative sine x looks like this. Instead of going up, it goes down.